Hello, my name is Ann, and I'm delighted to welcome you to our joint webinar hosted by global mold-based supplier DME and CAD/CAM specialist Cimatron. Today, we're lucky to have Mike Raymond, Director of Engineering, and Jeff Sarnecki, Regional Sales Director at DME, who will present some of the latest developments and new products within the DME portfolio. From Symatron, we're also joined by Ralph Piccolo, Director of Sales, and Dan Branch, Technical Support Manager, who will highlight the efficiencies and benefits of using standard mold components within your 3D tool design. Please note this webinar is being recorded and a copy will be made available after the session. Throughout the presentations, we encourage you to post questions in the chat as we'll pause between each session to answer some of the questions. If you like what you see today and would like to be contacted by a DME or Cimatron representative, please be sure to hit the Contact Us button in the chat window and leave your details. So we have a lot of great things to see today. Let's get started. Mike, Jeff, over to you.
Thank you, Ann. Thank you, Cimatron team. DME has launched 4 new product solutions to address plate sequencing, undercuts, alignment, and venting. So getting into plate sequencing, multi-plate tools are very common within the injection molding world. They're used for part ejection, stripping gates and runners, in addition to also including multi-stage ejector applications. Sequencing these plates are very critical so that the molds operate correctly. And with that, DME has introduced the Easy Latch.
So in this application, we'll show you 2 different latch locks that we're using on this one mold. Notice that they're mounted on the outside of the tool. In the first application, we're going to run a 3-plate mold running off the A side to strip a runner. Here you can see the A and B plate being pulled back, creating the space to drop the runner. When it bottoms out on the housing, it pulls the stripper plate forward, removing the runner from the retainer pins. In this application, we're going to sequence the plates. The top plate has the lifters attached to it, which are being pushed forward to release the undercuts. The second sequencing plate has the ejector pins in it, which will push them off the part. So with that, let's take a better look inside these latches so we can see how they work. Notice the cam action that's red in here. We removed the springs so that there was no wear or breakage of this, which is very common. Here again, we attached the dual ejector system using the latch locks to sequence these plates. So with the latch locks, we offer 3 different series for different sizes of molds. We got 3 body sizes for each of the series and 5 latch bars for each of the lengths. The bodies themselves are made out of 50-140. The latch bars are H13, 46 to 48 Rockwell, along with the returner. Everything is nitrated and black oxide for smooth action. And with this, if there's a few questions.
Not seeing any in the chat right at the moment. Let's proceed to the next session.
So another common challenge within plastic parts are undercuts. And a very common way to address undercuts is using lifters. Lifters can be purchased as off-the-shelf items. They can be made as customs, or they can be made as a combination of both. Whether which ones you use, the challenge is breakage. So the DME team developed what we call the Aculine lifter system, which implements a couple different features of auto-tuning or auto-alignment to prevent breakage as the lifters are installed, with just overall tolerance stack up and thermal expansion. And we'll address these issues within the next video.
So in this video, we're showing you two different lifter styles that we carry. We got the round lifter bar, and this one happens to be our coolant lifter rod. And we have a rectangle lifter bar. As you can see, we developed a different style of trunnion. We call it a shoe. The shoe has been wire EDM'd to accept the adapter ball, which is carbide, for a nice smooth track. And I'd like to stop the video right about now. Okay, so I want to discuss this a little bit. Notice that we have a dovetail on our lifter bar itself. What we've done here is we've created this so that we can handle the thermal expansion. I mean, as you know, your mold grows, but your ejector plate isn't exposed to the same heat profile as the mold itself. So as your mold grows, it creates a binding action. And by able to put in this dovetail, that it will grow and it'll adjust by itself automatically. So that was the concept of using this dovetail on your adapter balls. And with that, we'll continue. As you can see, these adaptive balls automatically align to the angle that you need. Here we're showing you the carbide roller guides. They're there to protect the lifter bar and give it extra strength. In this portion of the animation, we're showing you our coolant lifter rod. What we're showing is a conformal cooling lifter head so that we can get coolant up there. They're easily assembled and installed in your tool, as you can see in this animation. So these are fully customizable for any lifter application. We can use them in both small and large molds. They're designed to stop breakage or binding. So I'd like to talk a little bit more about this. Okay, so as you can see on the left, it's the thermal expansion is the sample that we're showing you. I don't know how many times that you've had a lifter break in your experience, but if you get a part stuck, it has a tendency to bind or break that lifter. So in the upper right-hand corner is something that we like to discuss. This is our adapter ball. What we've done is we developed it so if you do get something stuck in your mold, that it will have a break point or a fuse in it so it doesn't destroy your lifter. You're just replacing the adapter ball itself. So it will take you a couple hours to replace this adapter ball compared to sometimes a week or 2 weeks to rebuild a complete lifter because there's no break point in it. And in the bottom picture is a picture of the shoe itself. The shoes are made from D2 and they're heat treated to 62 Rockwell. So these come in 5 different sizes: 1/4 to 1 inch in Imperial, or 6 to 25 millimeter in metric. There's 2 different travel lengths of shoes in each series. The shoes are available in 0, 5, 10, and 15 degrees, and we can make special angles to fit any application. The lifter rods themselves, there's 5 different sizes in both Imperial and metric. Available are bushings and snap rings for guidance of the round lifter rods. We carry a set of keeper keys to retain the lifter to the lifter rod itself, and a gasket that sits on top of the lifter rod if you're running coolant through that rod. The keeper keys themselves are made from 420 stainless, and they're heat treated to 48 to 52. Now the rectangle bars, the lifter bars, are H13 and they're 38 to 42 Rockwell. We carry 29 Imperial sizes and 20 metric sizes of these rectangle bars. And again, we can make specials to fit any of your application. And with that, if there's any questions.
I see a couple of questions in the chat. This one is from Gerard Van der Meer. Are these parts now available in the Simatron catalog?
Yes, these are available in the catalog now.
Great. There's another one from Gary Lewandowski. Could these lifters work in die cast tools very similar to injection molds under extreme heat, and how would they hold up?
That's a good question. Yes, they can work in die cast tooling. Everything has been heat treated to handle the extreme temperatures that go along with die cast. So they'll work just fine in that application.
Okay, let's proceed.
So the next area that the DME team addressed was mold alignment and the challenges that it presents. Thermal expansion, aged equipment, worn out leader pins, bushings, auxiliary equipment are different things that can affect how a mold opens and closes, especially in the final seconds as the cycle finishes and the mold closes. If you have standing cores, shutoffs, those can be very expensive if they start to wear out or crash. So with that, we've introduced the LT roller side locks to address that. And we'll explain some of that within this video.
So in this video, we're going to show you our new standard side locks. These locks were developed to fit into a standard footprint that's currently used throughout the mold industry. So the screw locations and the overall sizes are the same. Here, as you can see, you have a 30% longer lead-in, which is great for when you have crossover shutoff. So you're not busting your small cores going from cavity to core side or vice versa. And also there's a secondary lockup on it so that you can maintain a tight seal on your locks themselves. They all come with carbide rollers to help guide these into place. Again, we wire EDM these so that they're a perfect fit. You don't have to worry about having a serialized lock, as they all fit within each other's. So what I'm trying to show you in this portion of the video is how an old worn machine or a heavy B side has a tendency to sag on when your mold opens. And these locks have been tested. And you can see that we can handle up to a 5-degree tip on it, straighten it up, and allows you to come in perfectly straight so you don't wear your shutoffs. And hopefully your mold will run as smooth as that. So to let everybody know, these locks are, the LT stands for the lifetime of your mold. We'll replace them if you wear them out, which we haven't been able to. So with that, I'd like to explain a few more things. The locks are available in 4 different sizes, from 1 inch, 1.5 inch, 2 and 3 inch. Of course, we got the carbide rollers, and we carry 3 different steel types. So our standard is D2. We carry DC53 for high heat applications. So you can run your molds at 750 degrees and your locks will not anneal, move, or anything like the standard locks that are out there today. And what we did is we developed 440C stainless locks for the clean room application. To let everybody know that 440C is the type of steel that they use for bearings. So it's the toughest steel that I could find for the stainless steel locks. Again, they fit into the industrial standard footprint and they can easily replace other locks. We wire the locks so that they're all interchangeable. And this is great for, like, if you have a shuttle application where you're going to have one male and multiple females, depending on how many stations that you have in your shuttle. And with that, if you have any questions.
I see some questions here. Andrew Pelosi is asking, how is the ball attached?
Okay, well, this has to go back to the lifter itself. And the ball is silver soldered onto the frame. And that frame is a D2. And every ball is tested with 1,100 pounds of side pressure to make sure that it's stable.
Okay. Daryl Hefeli is asking, is there a load rating chart to guide applications?
There is, and that would be on our website. And
Okay.
I believe it's in the catalog also.
Thank you. Krishna Bomasati is asking, is conformal cooling available in all sizes or in only certain ones?
The conformal cooling will start at the 3/8 diameter. So we'll have 3/8, half, 3/4, and 1 inch. And they'll be available at the end of January.
Okay, great. And one more, what is the cost between these lifters and standard unilifters?
The costs are relatively the same.
Okay.
I don't really go back and do price checks on our competition's components, but we price these accordingly, and we feel that they're a better system. And so they're priced according to that.
Sounds good. Okay, we're going to move ahead to the next session, but if your question wasn't answered, please join us in the expo where you can ask questions from the teams directly. And let's proceed.
So the next challenge that the DME team addressed was venting. Trapped gas can compromise part quality, causing short shots, burn marks, or messing with knit lines. And a real quick off-the-shelf solution is the vent pin, or I should say vented ejector pin. So if you get into a situation, maybe it's in a prototype or even a production situation where gassing is an issue, this can be a really quick solution. The pins in the larger diameters have 8 flats. As you step down to smaller diameters, they have 6. And as I mentioned, these are available off the shelf. They can be cut down and installed very quickly.
Okay. So as you can see, we offer multiple sizes in metric pins. The flats themselves are 0.038, which equals about 1.5 thousandths on our flats. And you can see in your F dimension the length of the flats on the pin itself. And then our next slide is our Imperial Offering. So as Jeff said, it's a good quick way of, if you have problems with gas buildup, it's a quick way to see how this will alleviate the problems by putting these vented ejector pins into your tool. And with that, is there any questions on our vent pins?
I see some more in the chat. Sam Viviano, do you plan on incorporating these into the top locks?
Okay, he's talking about the
roller locks, yeah.
The roller locks, yeah. Yes, we're actually working on those right now, Sam. We've done our prototypes, and we're going to be going into production levels in the next few months. So I'm planning roughly around March, April timeframe to bring these out.
Okay, sounds good. I want to thank you very much, Mike and Jeff. And just so you know, as I mentioned, the DME team will be available for questions after the webinar. Now I'd like to discuss how these latest product developments would be used in your Simatron tool design. Dan, take it away.
Thanks, Ann. I'm Dan Branch, Tech Support Manager with Cimatron. And for over 30 years now, Cimatron has been a solution of choice for mold design and mold manufacturing. So, like DME, we've been in this business for a very long time. But for those of you who may not be very familiar with Cimatron, we are a fully integrated CAD and CAM software solution. And we specialize in the design and manufacture of molds, dies, and fixtures, especially complex tooling like automotive work. I think the slide here really says it all. It's the power of having one system for the entire tooling process, combined with a huge amount of purpose-built tooling functions that brings our customers so much success and productivity. Really, increasing productivity is what today's webinar is all about. I think we all realize the clear benefits of using standard mold components. You get a wide range of well-engineered parts to choose from that come with a consistent quality and a reasonable cost. So next, let's talk about how your mold designs can maximize the advantage of using those parts. First and foremost, that means having access to a huge array of ready-to-go components for molds. But it also means having the tools to quickly identify the correct size and simplify its placement in the mold. And also the power to quickly edit and change the design if it's needed. And of course, an automated bill of materials to assist with the ordering process. We're going to go through a couple quick demonstrations. So let's get right into Cimatron and get involved in a mold design. At first, this looks to be a very simple open and shut mold design. But Quick Split also checks draft angles, and it finds undercuts relative to the direction of draw. So while these parts are pretty simple, the geometry that you see colored yellow is a warning to me. There are still features in each part that won't release until some sort of side action is defined for them. Cimatron runs this analysis on every part, and it's simply not going to let me miss an undercut feature by mistake. So one of the parts has molded clips, and the other one has matching indentations. Both of these types of features are very well suited for forming with an off-the-shelf standard lifter. So let's add some of those, and we'll do a few other components as well. The mold design is to the point where the part shape is already on a core block, and a standard DME mold base has been added. Let's take a look at that process for a sec. This is the screen for mold base creation or editing. And Simatron really has all of the DME configurations covered now. I can choose from an A series or a B or an X or a T series. Mud units and more are all here in this screen. And that is a lot to choose from, I know, but the system guides you through the decision step by step. For example, it can measure the parts to be molded and then recommend a mold base size back to you. In this case, I've chosen a T series to provide the extra floating plate that we need for the hot tip and the drop gates. Every part in this whole mold base is related and catalog driven, which means that any standard size can be selected. But really, if I had wanted to go non-standard, Cimatron allows for that as well. There's adjustable entries here for component locations and plates. The entire mold base is really just one big parametric assembly that I can adjust at any time. Moving on. The part shape is in the A side as well, and I've had time to add in a few necessary mold components. For example, DME easy latch locks have already been placed on either side of the mold. And as you just saw, these are a ready-to-go solution for controlling the opening sequence of the plates. And these locks do come in different sizes, as they said, so I had to go into the component catalog and choose the one that would best fit. And the parts of the latch lock are pocketed, they're bolted to the various mold plates. All of that was added as one unit. And we can look at how easy that process actually was as I add in a few more mold components here. So Simatron uses an applicative set of menus for different tasks in mold design. We think that adding a catalog part in CAD should be a very intuitive process. You need to quickly sort, choose the right size. Here I'm browsing the DME catalog, and it's showing knockout extensions because they were the last thing I happened to add, but now it's time for some side locks. And of the available types, I am going to choose another thing we just saw, those new lifetime series of roller side locks. Cimatron makes adding parts to an assembly very easy by providing several smart placement options, one of which is simply picking a point on a face. Then I get an immediate part preview, and that appears, and it helps me get the size and location correct. Side locks are another example of a catalog unit, several parts being added all at once. So selecting the right size here had better involve some interrelated dimensions, and it does. Changing the mail lock knows just how to resize the other components to match. Also, side locks, of course, they install across both sides of the mold, and the design I'm working on has separate sub-assemblies for each side. So what I'd really like is for these components being added to split up and go into both mold halves so that my structure stays correct. And that's actually what the option for editing the distribution can do. On the fly, I can assign different parts of the locks or cams or any group of parts to reside in different areas of the mold assembly, which is a really nice way to save the effort of rearranging things later on. Another screen option here is with cut, and that is definitely a good one to use. Cut means that I want the part being added to make its own holes and pockets in the plates, which I do. Now, by hiding those newly added parts, I can verify that the pocketing looks good. This ability to cut in the pockets comes right from the smart catalogs. The type of pocket and clearances are all relative to the parts, so no matter what edits may take place later, I can be sure that the plate machining work is going to be correct. Now, as expected, the B side of the tool received the rest of the side lock components and, of course, the corresponding mounting holes. So that's cool. Let's move on, and we're going to add a few more components to this design. Ejector pins are very important, of course, and I've already added in a few, but one part has some small ribs in it. And while these need help ejecting, I'm also concerned about trapping air down in those ribs. We head back to the catalog pages. Another new component I can use is the vented ejector pin. And as DME was describing, that fits the bill perfectly here. Now, whenever possible, Simatron uses automation to place well-known types of mold components. So I don't have to specify the plate an ejector pin sits on because a smart rule handles that. I don't have to specify the pin length. The system can calculate that too. All I really have to do is select the pin locations. Now, ejector pins are one of the components that get special treatment in Simatron. Being so common, a couple of dedicated functions exist to help speed up the work. One of these is for trimming the ejectors to match the shape of the part. It's just been completely automated. And then there's another function for doing the ejector pin holes. Now, these holes get a special function because it's nice to have some extra options for them, like varying the depth of the clearance drill hole back from where the pin's going to break out on the part. So a quick section view with the hatching turned off is a good way to see how those holes turned out. And you can see all the different clear and fit diameters. And while we do have more to talk about, now seems like a good time to break for any questions that have popped up.
This is from Madison Jones. What simulations does Cimatron offer?
You know, that's a bit of an open-ended question. There's one simulation I'm going to show in a minute, which is motion simulation. Actually, you can do, I see the question's been modified to mold flow. We have a partner, MoldX 3D, that you can incorporate into Cimatron in a way and do some mold flows with that. So again, if you talk to sales, you'll get a possible solution for that.
Thanks. Let's proceed.
Okay. So, you know, before we keep going with the mold design, you may be wondering just where all these catalog parts are coming from. So let me show you the utility that handles that. This is the Cimatron catalog part server. Here is where we provide the users with an ever-growing collection of our native data components from key suppliers like DME. And inside a catalog, you'll see all of the parts and mold bases that are currently available. Now, generally, you'll have the entire contents downloaded to your PC, but this utility is also linked to a cloud-based catalog server. So that means it's going to notify you the minute any new or updated catalog part becomes available. And that really simplifies staying up to date with the new product advances. So if I sort this here to show only what's new, it's going to reveal that just one recent update since my last check-in here. And the utility has a single button to download what's new and place it right into my local catalog folder. So this is really just such a nice and easy way to obtain the catalog parts or load them on a new PC or just check for the latest update. Okay, well, now it's really time to look at placing some lifters that will mold and release the undercut features in these parts. Let me turn off a few plates so we can see a little better. And then I'll be heading back into the DME catalog again, this time for one of the new style Aculine lifters. And I could add each individual lifter part, but I'd much rather, place the entire lifter assembly all in one operation. And those are here too. I want to locate the lifter assembly in the ejection system and then add a reference from the part to align it to the undercut feature. And for the moment, I just want to get the lifter in a rough position and then think about how it's all really going to work. Because a lifter mechanism like this has several important parameters and they all work closely together. So far, I'm just seeing a preview of a certain size and it may look pretty good, but there are a few things I can make obvious adjustments to. And that's all in one handy catalog table. For example, the lifter angle. So that's related to the depth of the feature being molded, of course, but I know I can get by with just 5 degrees in this case. Also, the height of those lifter bar guides. Those guides are really a nice feature of these Aculine lifters. So that's a dimension to adjust, or you could even make a smart relation to the plates for it. Even where that lifter ball sits in relation to the shoe is an adjustable dimension here. And then the most important ones are probably the size of the lifter bar itself. So the size of the bar actually is what drives this entire lifter assembly. If the bar gets larger or smaller than the recommended shoe and the other components, all have to switch sizes too. And only Cimatron has worked with DME to make sure that these parts all work together in the recommended way. So all of that adjusting probably means repositioning the lifter a little bit, which is as simple as changing the dimension, of course. And then I do want the cut option on for sure. So I get all the tapped holes and pockets for all these parts that we're adding installed. That's done. Let me just put a few more of the mold plates back on so that when we look at another quick section view, we can really see what all took place. Every pocket for every lifter component has already been correctly created in the plates. So with all of that handled automatically, I really only have one other task to do. So the top of the lifter still needs a part shape on it. So that geometry was in the core block, but the lifter pocket took it out. And that's exactly why we have another dedicated function, one made just for lifters. It knows how to get the part shape right from the original quick split part, apply it, and trim the lifter bar off. And I know that this mold design needs several more lifters. It needs various other components too, some of which we're probably going to talk about during a follow-up webinar with DME that we're talking about. But for today, I need to move on and look at how I can get all these parts ordered. So Simatron keeps a running bill of materials in the job. And it can be set up with any number of columns, but most everyone wants to see the quantity, part number, material. So these and a few others are all in the BOM by default. Now some users will take this bill of materials and they'll add it to a drawing with balloons, but others want to export it, maybe to a format, perhaps an order for the purchasing department. So here, any custom Excel template can be set up for that purpose with whatever data and graphics that you want. But as DME allows for bulk ordering on their online store, you may want to just export using the eStore template that we've already put in here. And this particular output is designed to comply with the DME ordering system format. So really, this document is something you can drop right on their website and then know that everything you need was received and is going to be heading your way. And we're quickly jumping here. I want to finish up today with a look at mold design verification. The last thing you want to find out on the shop floor is that some aspect of the mold has a bind or a collision in it, but all of the different kinds of mechanisms that we're designing in the tool are designed at rest. So there's a real value in testing the mold actions to make sure everything is free to move as it should. But if you're going to do that, it has to be a real test, a kinematic analysis of each component as it moves in 3D space. And that often means contact with other components and they go into motion. So it can be a very complex system of events to check. Cimatron motion analysis is a true kinematic engine. So here I've got the mold further designed and I've already ran a test. The only defined input force was the ejector stroke. All the other motion that you're seeing is resultant. The pieces are moving in the only way they can move based on the design I made. So components like pins and lifters can only follow the holes that were made. And the result of that, of course, is the ejection of the part. But what I was doing here isn't really just a test of part ejection. Those AccuBar lifters have to slide in the shoes. And in the motion, I get to see a real view of the travel they go through. And I'm also very interested in the green lifters on the right, as they were the ones I designed with the angled shoes that DME offers to accelerate the lifter travel. And the fact is, the motion analysis here did find a collision. So I can ask the system to specifically highlight that. I ran this analysis with the full ejection travel. And now I see that right at the end, the green lifter adapters make contact with the lifter guides. And that's exactly the kind of very easy to miss mistake I was worried about. Running a simulation here saved me some trouble. Now I know I have to pocket these lifter guides deeper or maybe add some ejector stops into the system. And that's it. That's our short demonstration on the features and benefits of designing molds with Cimatron, along with interactive standard components from DME. And it's really just a portion of what we can show you about our integrated CAD and CAM. It's designed just for the needs of tool shops. We know that Cimatron can help boost your productivity and provide a competitive edge for your mold builds. So thank you very much for watching that. And now we'll pause and see what other questions we may have had.
Okay, well, I see one from Gerard. He was asking if you'll be available to discuss some things about his Cimatron seats after the webinar. Dan, I can answer that. Will be available with Ralph along with Mike and Jeff in the expo area to answer some questions, and then Dan is always available to help and support Gerard. So be assured that will happen. Okay. Madison Jones says, very cool. Can you export BOM's Solidworks, or can you create drawings in Cimatron?
Cimatron is full CAD and CAM, and that includes a wonderful drafting area. So yeah, you can make drawings that are fully detailed. In fact, you can automate drawings because we use a templating thing. I don't want to say push button, but very easily you can get mold layout drawings. You can add your bill of materials, balloons, all the stuff that you would expect. As far as exporting the BOM, it exports to an Excel doc or, different types of formats, like I was saying. So as long as SolidWorks can read one of those formats, it can go in there too.
Okay, and finally, Christopher Lissel says, thank you. Chris and Claus are from Accuratech are very impressed with the software.
Well, I'm glad to hear that.
More of a
lots we can talk about besides this. Yes.
Exactly. All right. Well, those are the questions I see, and Madison Jones thanks us. And I want to thank you, Dan, and the whole group here. The Simatron team will be available after the webinar to take additional questions, as I was mentioning. And I'd like to close by thanking our presenters from DME and Cimatron. If you like what you've seen and would like to learn more about it, please visit the expo. The icon is on the left. You got the little diagram there. And as I mentioned, I'll mention again, both teams, the DME and Cimatron teams, are heading over there immediately following this webinar. They'll be there live and they can answer more of your questions. The expo also allows you the opportunity to view product videos and download additional material. Finally, if you would like to discuss any other topic or would like to arrange a company meeting, please be sure to hit the Contact Us button. We'll be in touch shortly. Thank you so much for your time today. Stay safe.